All right, AI SL2 kids, we are nearing the end of our derivative unit, and today we're going to do a derivative word problem, since that's all your homework is word problems. Yay. Okay, we're doing a dog food problem. A can of dog food contains 500 centimeters cubed of food, so that's a volume right there. They also did not provide you with a drawing of a dog food can, so I did my best job at drawing a cylinder for you. The company wants to minimize the surface area of the can, which makes sense. Like if you had a company and you had to pay for labels and stuff like that, you would want to do the least amount of production you could, because it would cost less for the labels. The radius is, we're going to call r centimeters, and the height is h centimeters. We're going to find the dimensions of the can. So here's what's going to happen. We're going to use a bunch of formulas that are found in your formula booklet. And then afterwards, we're going to apply derivatives and then turn towards our graphing calculators to handle this problem. So first things first, from your formula booklet, you can find this formula right here for a cylinder, that the volume of a cylinder is pi r squared h. Also in that same section, you can find that the surface area of a cylinder is 2 pi r h plus 2 pi r squared. Now, they tell us that the can is going to have a 500 volume. So, we can set the volume equal to pi r squared h. Now, you might look at that and be like, well, this is kind of silly because, there's two letters there. We can't solve that. There's an r and an h. But what we can do is get the h by itself and then plug that in to the surface area equation. So I'm going to divide both sides by pi r squared. So 500 over pi r squared is equal to h. Now we're going to take that h, the 500 pi r squared, I guess I should circle this, and we're going to plug it into this h right here. So now surface area is 2 pi r times h, but h in the other equation was 500 divided by pi r squared. And then it's going to be plus 2 pi r squared. Now, this is the surface area equation for a 500 centimeter cube dog food in terms of radius. What we're going to do first is clean this up a little bit. Because if you zoom in right here, these pi's will cancel out, and also one set of r's will cancel out. And then the 2 times 500 will give us 1,000. So, just a quick rewrite of this. This will become 1,000 over r plus 2 pi r squared. Now, we need to find when this is at a minimum. This formula will be at a minimum when the derivative is equal to 0. So, to find the derivative, we first need to take this and kick it back upstairs, which we've done in a few problems. This will be 1,000 r to the negative 1 plus 2 pi r squared. And then, if we take the derivative of this, so ds dr is equal to, bring the negative 1 out in front, so this is negative 1,000, but then you have to drop the r down by 1, so that becomes r to the negative 2. Here, the power on the r comes out in front, so this will be plus 4 pi, and then drop the r down by 1, so that's just r to the 1 power. Now, we have the derivative, and when the derivative is equal to 0, that's either a maximum or a minimum. So we can set this equal to 0 and try to solve. Here's the deal with trying to solve that. It can be done with algebra, but it's kind of past the algebra skills of this course. So I'm going to show you guys how to use something on your calculator called Solver. So I'm going to briefly explain how to use Solver in this video, but I'm also going to post a video that somebody else made that's pretty good about how to use Solver on a calculator. But you essentially just hit the Solver button, which you'll find under Math. So if you go Math, the Math button, and then arrow up to Solver. Once you hit Enter on Solver, you're going to see a spot where you can enter an equation. That's where you're going to plug in this equation right here using the X button for the R value. Then once you hit enter on that, it doesn't actually work right away. It's kind of funny. You have to make a guess, put a guess in there about what it's closest to. So I guessed that it was like, 5 or something like that. And then you hit alpha and hit solve. So I'll put a little bit more of these directions in here. Input equation. And then hit enter. Then you make a guess. And then you hit alpha. Solve, which is the enter button. When you do that, you get R is equal to 4.3. Now, for some reason, your book thinks that you should check to make sure that's a minimum by putting like a 4 and a 5 into the derivative function. So when we check ds dr at x is equal to 4 and x is equal to 5, they're basically doing what I call a zone test. That if you look at like a number line and you put 4.3 right here, which we know that's a turning point because it's when you set the derivative equal to 0. And then if you plug in a 4, if you put a 4 into the derivative, into this function right here, you will get a negative number. So here it's negative. And then if you put a 5 in, you get a positive number. It's like 22.8. So this is positive. Which means if you think about the graph, it means it's going downhill to the left of 4.3 and uphill to the right of 4.3, which means it's a minimum because it goes downhill and then it touches 4.3 and then it goes uphill. So this is when the original function is at a minimum. So that means the radius is 4.3. And if you plug that back into this equation right here to figure out what the height is, so if we do height is equal to 500 over, what was it? Pi r squared. Pi 4.3 squared. This is equal to 8.6 centimeters. So radius is 4.3 centimeters. Height is 8.6 centimeters. So, to recap exactly what happened in this problem. They told us that we needed a dog can with volume of 500. So they wanted this volume to be equal to 5 hundo. From the formula booklet, we set that equal to the volume equation and then got h by itself. And then they wanted the surface area minimized, so we plugged that h into the surface area equation. We cleaned it up to get the master equation right here. This is the surface area of the can. Took the derivative and set it equal to 0. Then the algebra was too hard for us right around here, so we turned to the solver in our calculator, and then using the solver, we found out that that derivative is equal to 0 at 4.3. Then we did a quick check to see if it was negative to the left of that spot and right to the positive of that, or positive to the right of that spot, to make sure we found a minimum and not a maximum. We did indeed find a minimum because it flipped from negative to positive. Now, I'm going to show you guys a way to check your answer without using derivatives. If you go back up to right here, this was the equation of the surface area in terms of R. S equals 1,000, R to the negative 1. So surface area was 1,000, R to the negative 1 plus 2 pi R squared. Now, you can graph this in your graphing calculator. Now, the thing that's weird when you graph it is your standard viewing window isn't going to look good, so you have to adjust your window. The main thing with adjusting the window is that, like, for the x's, or no, for the y's, it has to go from 0 to 500. So, because the dog food has like a volume of 500, so you have to do 500 on the y's, and then for the x's, you can go out from like 0 to 10 or something like that. That'll probably work. When you do that and you hit graph, you're going to get something that looks like this. Now, that's the curve of the surface area of the dog food can, and we need to figure out when it's at a minimum. You can achieve this by using the minimum function on your calculator. So you hit second, calc, and then arrow down to number 3, which is minimum. Then the way minimum works is it's going to ask you 3 different questions. It's going to ask you for like a left bound, a right bound, and a guess. So if you hit the minimum button, it's going to ask you for left bound, and just make sure you're to the left somewhere of that curve. So, you know, pick a spot that's like right here or something. Then it's going to plop a little arrow up here and say, okay, I'm going to start looking for a minimum here. Then it's going to ask for your right bound. Make sure your right bound is somewhere on the right side of the curve, somewhere like here. And then it's going to go, okay, I'm putting an arrow here because I'm going to stop right there looking for a minimum. Then it's going to ask you for a guess. Your guess just has to be somewhere in the neighborhood of this. It doesn't even have to be that close. But then when you hit enter, it's going to tell you that this x is equal to 4.3. Now, that's the point 4.3 and 349, but we actually don't care about the y value of that because that's just the radius that you want. Oh my gosh. You would then still have to plug that radius into the height formula to be able to find, 500 over pi r squared. But feel free to check your answers doing this. But remember, come test time, I'm going to want you guys to actually take a derivative because that's the target, is that you can use derivatives with